Okay, so Microsoft just made an absolutely colossal gamble on the future of quantum computing. I mean, they haven't just moved the goalposts here, they've completely upended them. They just halved their previous goal and set this shocking new timeline that has the whole tech world buzzing right now.
3 years. Yep, you heard that right. 3 years. That is their staggeringly close new deadline. By 2029, Microsoft says they're going to have a practical, working, fully scalable quantum computer. And this is just a massive drop from their previous target of 2033. But here's the central tension we really need to dig into for this explainer. While Microsoft is out here projecting absolute, total confidence with this bold claim, the broader scientific community, well, they're pushing back with some deep, almost unprecedented skepticism.
All right, let's dive into this. Now, we all know the promise of quantum computing relies on qubits. Unlike your standard conventional bits, which are just stuck being a 0 or a 1, qubits can be a 0 and a 1 simultaneously. We don't really need to rehash the basic textbook stuff on why this tech is so revolutionary, but it is absolutely crucial to understand exactly how Microsoft is trying to build their specific qubits, because honestly, that's exactly where all this controversy is coming from. So it's this superposition that gives quantum systems their staggering power, right? It lets these wave-like states actually cancel out the wrong solutions, so the correct answer basically just naturally pops out. It's like magic, but it's physics. It allows a quantum computer to just chew through insanely complex problems that would completely overwhelm even the most powerful conventional supercomputer we have on Earth today. But as we know, that immense power comes with a pretty huge Achilles heel. And that Achilles heel is what we call the noise problem. These super powerful quantum states are incredibly delicate. If they get exposed to literally any noise from the surrounding environment, we're talking even just a tiny bit of heat or electromagnetic interference, they quickly fuzz out and just completely lose their quantum properties. This is basically the core bottleneck for the entire industry right now. And it's exactly why today's quantum computers contain at most maybe just a few hundred qubits, fashioned from things like superconducting circuits, single photons, or lone ions. They're simply way too fragile to scale up easily. So, to solve this universal fragility problem, Microsoft is taking a very unique approach. They're heavily focused on a highly specific, microscopic building block called a topological qubit. Their proposed solution relies on a somewhat honestly Byzantine design found in their newly announced Majorana 2 chip. The entire goal of this topological qubit is to make these highly delicate quantum states super robust, basically making them practically immune to all that environmental noise we just talked about. Okay, so building this physical chip involves 3 main steps. First off, they start with a base made out of semiconducting layers. Second, they lay down a strip of superconducting metal right on top of that. This actually induces a wire-like region of superconductivity in the semiconductor underneath, and in this region, electrons naturally pair up. Then, in step 3, a tiny electrode called a quantum dot injects an additional, single, completely unpaired electron right into the mix. So you might be wondering, how do they actually store and read data with this hardware? Well, it all comes down to some really crazy electron math. Within that wire-like region, if you have an even number of electrons, say exactly 10 million paired electrons, that represents state 0. But if you have that extra lone electron injected by the quantum dot, giving you 10,000,001 electrons, an odd number, well, that represents state 1. Microsoft then reads these states by measuring the wire's capacitance using another nearby quantum dot. And this brings us to the real theoretical magic behind their whole design: Majorana zero modes. In theory, quantum effects make these highly specific states incredibly tough. It creates this totally weird, delocalized state where that lone extra electron literally exists everywhere along the wire simultaneously. Because it's delocalized in this super unusual topological shape, it drastically reduces the chances of it interacting with the outside environment. It basically becomes remarkably resistant to any disturbances. And here is the dramatic breakthrough that actually prompted this massive announcement. Back in 2025, Microsoft achieved these states using traces of aluminum, but they only lasted for about 2 milliseconds before they just flipped and failed. But now, by switching the material from aluminum over to lead, Microsoft claims these quantum states last a staggering 20 seconds. Let that sink in. Going from 2 milliseconds to 20 seconds is just a monumental leap in stability. It's a real game changer. So the crucial point here is how this massive leap impacts their overall schedule. Chetan Nayak, who is the physicist leading Microsoft's quantum computing efforts, stated, "We've talked about a scalable quantum machine on the 2033 timescale, and we believe that these kinds of accelerations can bring that into 2029.
So it is exactly this specific 20-second stability milestone that's giving them the optimistic stance to just aggressively hit the gas and accelerate their timeline to a mere 3 years from now. But remember that tension I mentioned at the very start? Well, here comes the intense scientific pushback. Sergey Frolov, a physicist over at the University of Pittsburgh, offers a very harsh rebuttal to Microsoft's whole optimistic vibe here. He says the Microsoft Quantum project follows a sustained pattern of unreliable claims, so the new ones are not surprising. Ouch. I mean, that is a brutal assessment coming from a really prominent voice in the field. So let's break down exactly why the skeptics are so fired up about this. Physicist Henry Legg points out several major red flags with this supposed breakthrough. First off, actually achieving these Majorana states requires applying a really strong magnetic field and precisely tuning the voltage. Legg argues the data suggests the system might literally just be settling into a quiet spot in a landscape of noise rather than achieving a true, robust topological state. And furthermore, that cool switching behavior Microsoft is so excited about? Well, Legg says there's a much simpler, entirely incidental explanation. It could literally just be a regular electron hopping on and off a quantum dot, completely unrelated to these exotic Majorana states. And that leads us directly to the missing evidence. Critics are quick to point out that even if we generously assume Microsoft has achieved these Majorana states, their newly published paper completely lacks a demonstration that the device actually works as a practical, controllable qubit. You know, for a qubit to be genuinely useful, researchers have to actively control the device and ease it into different admixtures of its two states. That proof, it's simply not in the published literature right now. Plus, Legg notes a really critical technical distinction here. Just because a state endures for 20 seconds, that does not necessarily mean the actual superposition will survive for that long. Now, Microsoft is definitely aware of this criticism. Chetan Nayak actually acknowledges they've been somewhat secretive with their peers in the past, admitting, "We said, just trust us, we're going to make the topological phase more robust. Now we're revealing more about how we've been doing that." He goes on to claim that Microsoft absolutely does have the data, albeit currently unpublished data, showing they can fully control their qubits and even run real quantum algorithms on their chip. But honestly, asking the scientific community to just trust us is simply not working anymore. Just juxtapose Nayak's defense with this blistering comment from Sergey Frolov. You go to a conference and somebody mentions Microsoft and people are chuckling. It's become a joke and it's terrible for the field. Wow. How do you even reconcile a trillion-dollar tech giant's internal data with academics demanding rigorous, peer-reviewed proof? It just brilliantly illustrates the severe culture clash happening right now between corporate optimism and the strict scientific method. Which brings our whole narrative directly back to that ticking clock. The scale of implausibility here, at least according to the critics, is pretty staggering. To actually hit a 3-year deadline and deliver a fully scalable quantum computer by 2029, the general consensus is that Microsoft would need to have a fully working, controllable prototype running in the lab today. And based on what has actually been published and verified to the public so far, skeptics are basically calling that 2029 scenario virtually impossible. So, we are left with a massive question, perfectly framed by physicist Henry Legg. Is Microsoft genuinely on the brink of a technological revolution that will literally change computing forever? Or have they just convinced themselves of conclusions their data doesn't actually support, heading straight toward a quasi-religion crash on Judgment Day? Well, they've set their own timer. By 2029, we are all going to know for sure if this was a historic revolution or just a massive miscalculation. Until that clock runs out, thanks for joining this explainer.